Now example 5.5. Answer the following. A. The casing of a rocket in flight burns up due to friction. At whose expense is the heat energy required for burning obtained? The rocket or the atmosphere? So it is obtained due to rocket itself or by rocket itself. Okay, so burning of casing of the rocket in flight is obtained from the rocket itself, right? It is obtained at the expense of the mass of the rocket and its kinetic and potential energy. Okay. Then B. Comets move around the sun is highly elliptical orbit. The gravitational force on the comet due to the sun is not normal to the comet's velocity in general. Yet the work done by the gravitational force over every complete orbit of the comet is zero. Why? Because we already discussed this thing. The gravitational force, that is the conservative force, and for conservative force the work done on the closed path, that is always zero. Clear? Then see, an artificial satellite orbiting the earth in very thin atmosphere loses its energy gradually due to dissipation against atmospheric resistance, however small. Why then does its speed increases progressively as it comes closer and closer to the earth? Because when it comes closer and closer to the earth, its potential energy decreases, and when we neglect this atmospheric resistance, here it is given to you, however it is small, then we can say the total energy is almost constant. So when potential energy decreases, kinetic energy increases, and therefore its velocity increases or speed increases. Okay. D. In figure 1, the man walks 2 meters carrying a mass of 15 kg on his hands. In figure 2, he walks the same distance pulling the rope behind him. The rope goes over a pulley and a mass of 15 kg hangs at its other end. In which case is the work done greater? Now see here, in this first case, the weight, that is mg, and displacement, that is in horizontal direction. So force and displacement are mutually perpendicular. So in first case, the work done, that will be equal to 0. Clear? But now if we think about second case, then see here, man is applying the force on this particular object by this rope. So here the pulling force, that is in this particular upward direction, and displacement, that is also in upward direction. So here if man walks 2 meters, then displacement of this body, that will be 2 meters in upward direction, and a pulling force by rope, that is also in upward direction, right? And this work is done against the gravitation, that is in downward direction, mg. So here work done, that is mgh. So 15 into 9.8 into 2, so that is 294 joule. Here you can take 10 also, so you can write 300 joule. So in second case, the work done, that is greater than the case in 1. Clear?